Okay, for example, what is F00? This is partial of 0, A0 minus partial of 0, A0. Clearly, this is 0 whenever pareho sila, no? Sa ato pa, these are all 0. Sa ato pa, F, I all equal to 0. How about 0, 1? F01, did we be partial 0, A1 minus partial 1, A0. Okay? What's partial 0? This is minus partial 1 over C. By the way, what's our A? Sulat na nato balik ato ang A. Our A mu would be what? A mu would be phi over C. Phi over C, A1, A2, and A3. Okay, sa ito pa, this is, asa ang, this is 1 over C, partial over partial T, A1, minus, unsa ni siya? Partial over partial X, A0 of phi over C. And, okay. What is this? What's AI? A1, A2, A3. Ano siya value? Look at the, usan nga gauge nga itong gikuan? No. Unsa man ni siya? Kani siya, unsa ni siya? This is, we can actually find the components of this. Dire. How? This is vector, right? Vector. Do you have partial, unsa man ni siya? Mahimo ni siyang partial phi x, I hat, j hat, napog kay I hat, j hat dire. And what you get is, bugawas ni siya, right? Kaning dire. Imo siyang itandi-tandi dito. Kapoy. You have what? E1, EXI. Okay, anyway, in vector form, this is actually what? EX, EY, EZ equals what? This is minus partial phi over partial X. Right? Partial phi over partial Y. Partial phi over partial Z. Minus, unsa na po ni? Partial A over partial A, this is X. Partial AY over partial T. Partial AZ over partial T. Now, manggawas ni siya. This is actually partial A1 over partial T. Right? Kani siya dire. No? Compare that one dire and you will see that this is actually equal to what? EX over C. Now, if you derive all, I want you to do this. I will not do all the derivation because we have no time. It takes a lot of time to do this one. We have, well, this is a anti-symmetric tensor. That means that we only need to evaluate, well, kaning diri upat, wala na, kay zero man itanan. And we only need to evaluate here kay kung unsa ni siya, negative lang ni siya diri. Notice, by definition, we know that this is anti-symmetric, right? This is an anti-symmetric tensor. So, pag ana atong kuanon karon, ang mahitabo karon would be what? Okay. We only, pila ka atong unom ra, actually. 1, 2, 3, no? 1, 2, 3, 4, 5, 6. You only need the 6. No, but it's, again, it's takes quite, you have to do that. In the exam, tagana ta mo isa ka question sa exam karon. I'm going to ask you either what is F mu nu or F mu nu. Derive na ninyo. So, okay, so I'm not going to derive every term in the electromagnetic field tensor because it takes a lot of we have no kumbaga pa no, we are actually running out of time, but you will find that F, and in fact the derivation with daghan kay references din yo, I will refer you to the references. We have now F mu nu is actually given by 0 Ex over C, Ey over C, Ez over C, and then this is 0, the electromagnetic field tensor. And you will know that the electric and magnetic fields transforms like a second rank tensor together. Why? Because the two are actually, mo nagingon nga, they are not separate. No, they are actually, they are, kumbaga pa, the electric and magnetic fields are two sides of the same coin. You can see, think of that. Changes in magnetic field leads to electric field. Changes in electric field leads to magnetic field, no? Now, what I want is actually in fact, medyo taas-taas na gid ang kaning language. Mo yung language sa field theory. We are using heavy we're using covariant and contravariant ng mga kuan. Okay, for example, how do you arrive at F mu nu? What is F mu nu? F mu nu is what? Well, you contract F, what? Alpha, beta. So you have G mu, di ba? You contract, you lower or raise index by what? Multiplying it with the metric tensor. So sa ato pa, this is mu alpha times G beta nu. Nganong ani siya? Why do you think nga ani pagkasulat nako? Well, in many books, the definition is just like this. G mu alpha, not definition, they write this as this. G beta nu F alpha beta. And in fact, the last time I wrote to you is like something like this. Well, because although pareho na siya, no, these are scalars. So you can actually interchange. But the point is, these are actually matrix multiplications. Now to write this, try to write it this way means that you are to multiply this one first, and then after that kani. Nakuha? Sabtan? So, because this is metric multiplication, di ba? Beta, beta, alpha, no, right? This is the matrix multiplication. And this one is also matrix multiplication. So, pwede gyapon ka na. Now, what we want, okay, by the way, this is, okay, kani siya. So, you lower the index mu nu by this. Okay? Let's see how the electromagnetic field transforms under the Lorentz transformation. By the way, sa atong language nga gigamit, we discuss tensor algebra. Lorentz transformation is a coordinate transformation. How do you think we express this one? As a contravariant type rank 2 tensor, or a mixed tensor of rank 2, or a covariant tensor of rank 2? Which do you think? It's a coordinate transformation. I showed to you, remember, sa katong ano nato, from how would the vector transform under coordinate transformation? What is the matrix there? Right? In fact, unsa to siya nga matrix to sa transformation. What we got? Unsa man? Unsa to yung matrix ato? What? When we did the transformation, we had the Jacobian matrix. Right? Or the yeah. Now, we now write the Lorentz Transformation matrix as, I'll just use L. Kay lisod, ang gigamit sa, actually, Griffiths, and I think most is like this, no? But I want to use L. Okay? The Lorentz Transformation matrix, again, let's use, to simplify calculation, okay, wala tayo, di taka-avoid, no? We will use the actual, no? I want to use C equals 1 on top, because if I'll use C equals 1, this will simplify a lot. It doesn't, pero basin ma-confuse man gud ang sige na lang, I'll just use, I'll just use general. What is L, L, I, or L, mu nu, L mu nu, the Lorentz transform matrix is, this is gamma minus gamma beta, and this is, okay, we are actually taking only the transformation along X. The boost is along X. No, the Lorentz boost is only along X. We can have the boost in any in any direction that we want, no? But well, to simplify things, just to show you, maybe I'll let you do the general case, no? Kapoy manggod. We'll just use this. Minus gamma beta 0 0 minus gamma beta gamma 0 0 0 0 1 1. That would be the Lorentz transformation matrix. What's gamma? That's 1 minus v squared over c squared. No? Gamma is 1 minus v squared over c squared. Now, how does the field transform now? If this is F mu nu, what is now F mu nu prime? Well, this is a tensor, second rank tensor. So how does the second rank tensor transforms? This transforms according to what? Well, dapat ka ano naman mo nang ako gining tarong nagdugay gyud ta dire kay paninglang gyud ta mo ani. Your final exam will be tensor ang mga language. Okay? Okay, katulon si ko Marby. Okay, L mu nu, this would be, asa dapat ang mu? Kay mabilin man siya. Meaning, this is sa taas, right? Natay alpha dire. F what? Of course, alpha, it must be up dire kay, di ba, up, down atong summation. And then beta, L what? L, asa ang beta? Beta nu. Now, notice nga mu alpha beta nu, lahi ang L mu alpha and L beta nu. Diba? Right? Pero, why problema kay kani symmetric man eh. So, sa ato pa, bisag kung saan nato nagbali-bali, okay ra na siya. But whenever the tensor is not actually symmetric, there's a problem there. Kay lahi ang meaning ani, ang una, di ba, naman kay idwa ka index sa taas. Pag i-mix nimo, depende og asa mauna og sulat, no? Sa in terms of column, mao to ang gibaba. Okay, so sa ato pa, this is equal to what? This matrix, ay, kulang pa rin ay, sorry. 0, 0, 0, 1, 1. Okay. Sige, nagkasayo pa. Ga-video ra ba ko? Sorry. Na-excite lang, God. Excited lang. Okay. Okay. So this is what? Gamma minus gamma. Ako lang gamihan ang writing, ha? Beta 0, 0, 0, 0 minus gamma beta. Makita ba sa video? Kita ninyo diha? Wait lang. Ay, no, makita. No. Maklaro ra. Gamma 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1. Times the electromagnetic field tensor. Agay. Ato sang iurong be. Okay, na-off na pod. Murong si Kwan ba si Dili si Kwan si Jason Momoa ba? Jason Momoa. Grabe oh. Okay, anyway. Sige. Times 0, 0, 0, 0, 1. Okay. Dapat makabalogin mo ani no? Kay kamo ang masiro noon pag di mo kabaluan eh. Okay, now okay, unsay unahon nato di ba dire? Okay, sige, do this. Si kanya-kanya tag ano be? Multiply, okay, 16 mo kabuok. Ikaw kani para dali. Bernard, you calculate this first. I-calculate nimo ang 0, 0. No? Ibig sabihin, kana imuha no? Kabalo man ka mo multiply. Okay, ikaw 01, 02. Sophia 03. Okay, so this whole thing here is this matrix times na again the Lorentz gamma minus gamma beta minus gamma beta gamma 0 0 0 0 0 0 1 0 0 0 0 1. Okay, this is a very good exercise, no? Okay, so kanina lang. Sige, unsa ni siya dire? Unsa ni siya? This is row 3 for ano? 0 0 bx 0. So this is bx. So this is minus bx. And we're done. Okay na? Ay dire. Unsa man ni?
Ay, sir, kini kay dire.
Ang saa?
Or na 4/5 naman lagi ni sir.
No. Mao ni ang atong element ba? Kani atong tungaon ha. Kana.
Ang kini grocery dire, ang kini din.
Ayawa na 4/5 naman eh.
Wala ni.
Ay kani ang bx. Dayon kani ang 0 0. Kani unsa man ni?
Wala nga sir, ang kini kay dire dapat.
Kani kay ayaw. Kani kay dire.
Kini sir.
So minus gamma easy over c minus gamma beta by. Asa? Kani kay dire. Sakto dili uy. Dire ma tama no? Wala na ni no?
Wala sir.
So kani dire minus bx. So kani ana lang nato no? Kana siya dire. Okay. Okay, now sige balik. Okay, so we have this calculation. So we have this, gikan dire, we multiply that one, we have there one. But note that this is f mu nu prime, right? What is f mu nu prime? This must be 0, 0, 0, 0. This must be the same as minus ex over c prime. Kasi prime naman eh. Meaning that we are just, f mu nu prime should be just the same. Pero i-prime nato dire. And then ato na siyang i-match dito, right? No? I-match nato. So you have ex over c. And then, usa ganini siya? No, this is positive, right? And then this is ey over c. And this is ez prime over c. This is bz, right, no? bz minus prime. by prime. This is bx prime. So this is minus bx prime. This is minus EX prime over C. This is minus EY prime over C. This is BZ minus, this is prime. And then this is minus EZ over C. And then this is BY prime, 0. Okay. So, comparing these two equations together, that means that EX is this must be equal. So, what do we conclude from that? What do you conclude from that? Sa ato pa, EX prime equals EX. Right? It means that the X, we are, asa na atong boost? Atong boost actually is on the X. So that, actually this is in variance. EX prime is equal to EX. Doesn't change there. Yeah. The prime, no, the X component doesn't change there. Well, it should not. Okay, next is sato pa unsay next. Well, we know that BX, o tanawa ha, BX is equal to what? BX prime is also BX, right? Tama? So, here we have BX prime equals BX. Now, here, EY prime equals this. So, sa ato pa natay, EY prime over C equals what? Equals gamma EY over C minus gamma beta BC. Now, this will be related sa curl. So, from here, kung sa'yo may tabuan this becomes, multiply by C, sa ato pa, this becomes EY prime equals what? You have gamma EY minus, that is beta B over C. Sa ato pa, kung sa'yo mato, mayroong gamma B, B, or we have this as what? This is gamma EY minus V, B. BZ, right? In fact, actually, it can be generalized that E parallel prime equals E, this is in vector form, no? E parallel. E parallel is equal to E parallel. This is EY and EZ, BY and BZ are perpendicular to the boost. We apply the Lorentz boost on what? On the x-axis. So sa ato pa, we have this one. E perpendicular, we have to generalize this one because this is what we get. No, we apply the Lorentz transformation to the what? To the electromagnetic field tensor. And see how every transform, if we do each one of this, like this one, dire. Now, I will not be doing all of this, kay taas kayo yun. No? But, there are lots of, you can read that one sa book. You have this generalization. E prime parallel equals E prime. And B prime, this is already a vector. Parallel equals B prime. Sa ato pa, it won't be. So here we found out how the electric field and magnetic field transforms according to the Lorentz transformation. Okay? They transform as an element of a four-dimensional tensor, second rank tensor. Because, di ba, in our tensor analysis, I told you that a vector would transform. You have a row vector times a matrix. Di ba? This is ana. If you apply this to the electric and magnetic field, it doesn't work. Why? Because in fact, the two vectors are not separate vectors. That's why it takes it takes a second rank tensor to describe them both. Because in fact, they are actually the same. No? And in fact, sa certain transformation dito nga, when B is equal to 0, okay, for the electric field, this is in S prime, right? This is the E prime here, B prime are actually in S prime. S prime travels at the speed of, not speed of light, travels at speed B. No? We're applying the boost there. Now, in fact, in generalization, as the special case here, if B is equal to 0 in E prime, in S, then in E prime, it would be B cross B. Sa ato pa, tanawa na ano nyo, ang consequence. It could be that for the special case that B is 0 in S, when this is 0 in E prime, tanawa. When this is 0 in E, this is prime. Tanawa. When E perpendicular is 0 in S, then in S prime, view it as, tungkol sa yung velocity, there's an electric field na ano niya. And that's just equal to V cross B. So, kindly check this one, ha? I think this is around beta B cross B. Because I have no time in actually confirming this. I don't memorize the formula. But something like this. It's actually B cross B. Now, how about when E is 0? How about when B is 0? Well, this is 0. This is in S. This would be in S prime. When B is 0 in S, there could be a magnetic field in S prime. What? This is because due to the velocity. Or in fact, or the other way around also. You can have the magnetic field. You can feel the magnetic field while moving. Or I mean, like, yeah. When you're moving, like, for example, this is actually a special case. Katong pinaka-ideal case. There's a current along the wire. Sa ato pa, there's magnetic field. But if you move in a way such that you move, your velocity is actually compensates with the velocity of the electrons or the source charges, what happens is that you have a static charge. And in that case, what do you have? You will only feel the electric field, but the magnetic field is not. Pero sa katong atlas ka, unsay naan nimo? The magnetic field is present, whereas the electric field is absent. But when you move according to the charges, mauni siya actually. No? And we see it the way, this is a very powerful mathematics. You see, na ano ninyo? We have seen this one. Now, it's a famous problem. I don't want, I di na ako siya i-solve diri karon so that we can proceed with the last topic yun. You can actually, there's a derivation on how the electric field, how the Coulomb's law can be applied in calculating the magnetic field by using relativity. And you can see a foreshadowing on that here. Right? Now, part now, what happens when 0 ni siya? It could be that there's still the electric field on the other side. Or that maybe when you are moving, 0 ni siya, pero sa original, naa siya. Right? Right? Pwede ni siya nga, 0 ni siya, pero naa siya sa original. Right? Let's actually look at how the equations transform. Okay, murag baliktad daw ang dire. In fact, Griffiths derived this one. I mean, in Griffiths' book Electrodynamics, he did not derive this equations by using this one. In fact, he derived this one by transforming it using Lorentz Transformation dito mismo sa physics mano-mano. Walay tensor pa. And because of this, he proposed that the electromagnetic tensor should be written the way that it is. Now, F mu nu equals partial mu A nu because of this curling dire, nga curl. And this, like, makita niyo nga right? So, from that, from these results, he derived the electromagnetic field tensor. And, mao gyapon na nakuha. Ang kaning approach nga giano nako is baliktad. What did we do? We used the action. We solved the action there in the Lagrangian by taking the variation. And from that, we found out that the vector potential would have some form. So that's why naano nato dito, no? Okay? So anyway, it's the same. Okay. Now, let's actually go back to unsay ato. Katong what happens to the Gauss's law? Katong isa, we have partial squared phi over partial, del squared phi, unsa ni siya, minus 1 over c squared, partial squared phi over partial t squared equals what? minus rho over epsilon naught. And partial squared A minus 1 over C squared partial squared A over partial T squared equals minus mu naught J. Now, notice that we are already in the 4 vector and that this phi here is actually part of a what? It's part of the ano. So technically, we can combine this. Tanaw na to ha. If we combine this one, not combining into just adding them, it seems that this is the spatial part and this is the temporal part. Diba this is the same? Remember, katong ngayon ako nga ano, partial, we define partial mu as what? 1 over C, partial over partial T, del operator. Tama? Now, kung tanawin ninyo, it looks like there is a, I'm not saying that this is a purely temporal, no? And this is spatial. But we can actually combine this into one single equation just by using this. Partial mu, partial nu, A, no, not partial nu. That is partial nu, A mu. Okay? I think this will be A nu equals what? Equals some vector here. In fact, this vector actually is mu naught J mu. This is again a 4-dimensional vector. This one is a 4-dimensional vector. Kung saan siya nga, ano, this is the 4-dimensional current density. Look at this one. We can think of this as this row here. We can think of J, the 4-dimensional current density J, now J mu as what? Well, we use rho, C times rho, and then we have now the J vector for the spatial part. Nakuha? This is the temporal part. We can think of that as J, and yeah. Ha? Asa? That's zero. I think sakto na siya. No? Or we can actually think of this as del squared mu. The D'Alembert operator. Now this one will lead to this two. Okay? Or we can think of that as partial mu, partial nu. Partial mu, partial nu A mu equals mu naught J mu. Okay? Yeah, this is correct. Now, na ako'y wala gibuhat dire, and I want you to do this on your own, no? Actually, you have this partial mu F mu nu equals this is mu naught J mu, and this is partial nu G mu nu equals 0. Now, what is G mu nu? This is the dual tensor. Do not think of it as like the dual space nga, ano niya ba? It's like actually it's called dual kay you can arrive at this by changing this. This one is the dual tensor can be achieved by just exchanging the E and the B there. Oh, that's no, F mu nu is katong not this one, katong partial mu A mu A nu minus partial nu A mu, right? That is F mu nu. Okay? Now, once you get F mu nu, you can get G mu nu by kambyohanin mo tong E og B, ang E over C og B, and then B to E over C. You can exchange, I think, put a negative one, you can arrive at this, and you will see that this is 0. Nu and nu. Tanawa, take note of the index summation here. And then nu. These two are actually the Maxwell's equation, would summarize the 4 Maxwell's equation. This is the Maxwell's equation in 2 second-rank tensor form. So this is the Maxwell's equation in second-rank tensor form. Remember that the 4 equations are vectors, first-rank tensor. Dagan pa actually na, I mean, we have skipped some, but we have tackled the mga very important na although sa katong you do the column gauge, practicein niyo ha, what would be the equation, may tabo dito sa equation nga pag column gauge ang gamiton, and so on. Okay?